Hello and welcome. Wherever or whenever you are in the world, it's another session of our Webcast Wednesdays series. My name's Tim Robinson. I'm a developer advocate at IBM, and I'm here to talk to you today about test-driven development using Appsody, which is an open source project around IBM's application stacks concept. So this series will be a follow-on to the previous series that we had around DevOps topics, where both Matt and Oliver were talking about DevOps introduction. In fact, Oliver mentioned just briefly a little bit about test-driven development before in his last talk, DevOps for Beginners. So let's go through in our agenda here that we've got. Okay. So our agenda today is going to be covering a background, an introduction into what we're going to be talking about and why. Then we'll actually go into test-driven development, and I will provide some examples, live walkthrough of doing a programming exercise with test-driven development. And then we're going to switch over to talking a bit about application stacks, and then we'll wrap up by deploying the application to IBM Cloud. I'm going to pause for one moment here. Okay. Okay, so why are we caring so much about cloud native? This is something that is important for many reasons. And from a test-driven development perspective, what's going on is that we are seeing, oh boy, Scott, can I get you to kill the feedback on the audio? Yep, 20 seconds later. Okay, so apologies for that. We're having some technical difficulties as we work out our technique that we're doing for these webcasts. No, I don't, Scott. All right. So with cloud native applications, we are shifting to a microservices architecture where there are multiple components that are being developed by independent teams. Applications are being containerized and they are being delivered in a rapid way using DevOps methodologies. And additionally, in cloud native, we see elastic scaling and orchestration. But really for today, I'm going to focus in on the whole, how DevOps is driving the agile lifecycle and what that means for us as developers. So if we take a look at development and testing approaches from, say, like the past, like the old waterfall methodology, you'd see a very structured approach where there'd be initial analysis, figuring out what the requirements were going to be, extensive design work, and then a development stage where all of the features would be developed. And then there'd be testing and deployment. And one of the things to note about this is that this would be multiple weeks to months to the point where even testing is being performed. And in many cases, and this might not have been a good thing, but practice turned out to be that there were different development and QA and testing teams. And we shift over to today where we're using agile methodologies to be more responsive and deliver features as they're needed and review them with clients and customers. We're going to see a much shorter loop. So we have these iterations where we figure out the requirements for a current design sprint. We'll do the design work with the development and the testing, and then we'll deploy it, and then we'll review it. We'll do playbacks, and we'll learn from this. And this faster cycle means that testing has happened much earlier. So if I'm looking at something from a time perspective, I would have testing much later in the development cycle. Now testing is much earlier in the cycle, and it's a general notion of this idea of shifting things to the left. So now each time I develop some new features, I need to run tests. And I keep going through this through iterations 2, 3, and 4. Okay. When I look at this from a CI and CD perspective, this means that as I am working in these small teams, building these components for a microservices architecture, I really want to be able to run tests on every commit. And so I need to have tests. Now, some of these tests might be more than just unit tests that we'll be talking a lot about today. They might also be tests like code quality tests. They can be tests like security tests. But the main point here is that as we are shifting to this agile cycle where I'm doing CI and CD and I'm automating all of that, I need to be able to have a set of tests to run on every commit. So here's where test-driven development can come into play. I've been in situations talking to developers, and I ask the first question is, okay, so how many of you like writing tests? And nobody raises their hands. And then I ask, so how many of you write tests anyway? 3/4 of the room ends up sort of sheepishly raising their hands. Because we have to do it. We have to write unit tests. That's a must. Otherwise, that CI/CD process that I was describing a moment ago just does not work. We need to have the tests. So what test-driven development, it's not a new concept, but it's a concept which is appropriately timed for now. The idea here is that I am going to be writing code in two modes. I'm going to be writing tests. And so I need to think of my tests as actual code. And then I'm going to be writing code. So one of the rules of test-driven development is that I only write production code if it's going to fix a failing unit test. And I start by writing a unit test, which is just enough to fail. And then I write just enough production code to pass the test. And in the moment when I do the demo, you'll see this live, exactly sort of how this flows. And then once I've got a passing test, that's a point where I can take a look at my code in general, and I can do some refactoring. I might see duplicate code in my current production code, and I might want to do some refactoring or do some other kinds of logical restructuring. Now, for the sake of saving time, I'm not going to be focusing on doing a lot of refactoring of my tests, but that's also something that can be done, right? You can actually refactor your tests as you're doing your test-driven development so that you've got a tight set of tests and production code ready for unit testing and the eventual CI/CD process once you commit your code. So here's an example. What we're going to be doing today is I'm going to be using the Appsody application stack framework to work with the Node.js application. And here's an example test written around Node.js. You'll see in here we are using something called the Mocha test framework. That's something that's included in the IBM Appsody stack for Node.js. And we're also using an expression library called Chai. And so you'll see here at the top of this code snippet some areas where we're bringing in some dependencies for Chai for both expect and assert approaches. And then inside here, I've got a describe method, which sets up what I'm going to be looking at in the test. And then I'll do a little web request. And we see two kinds of ways of doing, sort of expressing tests using Chai. The first is with the sort of expect kind of style, which can be chained. So I can actually chain a number of different attributes into that. And then also the more traditional TDD sort of assertion approach, right, where I just have a simple test that I'm doing. So we'll see examples of both of these as we go through the exercise. So why is test-driven development a good thing? Why do this now? So as it turns out, one of the problems that we have with code in general is that we end up with lots of old code, and maybe I don't have good unit test coverage. And then I've got an issue that if I want to change my code, it's not really safe for me to do that because I just don't know if I'm going to break something or not. So with test-driven development, I'm always sure to have code that covers what my application components are supposed to do. And so that means even if we're changing code that's totally unrelated to a new area we're working at, in other words, today we'll be actually modifying some code over development that's not in the set of tests that we're currently writing. We'll have those tests to know the full set of tests so we can identify if things are broken by a change. It works a lot better. Okay, so before we start doing some TDD, I want to quickly introduce the framework that's called the Application Stack Framework from IBM. About 9 months ago, IBM created an open source project called Appsody. It's part of a series of open source projects around the developer experience. Appsody is an open source project which is evolving over time. But the main concept is that there is something called an Appsody stack or application stack. And the application stack captures a programming language and some framework and some other sorts of management choices for an application. For example, how do I build and test an application? On top of that, each application stack includes one or more templates. The templates are the starting point for a cloud native application. So from a developer, how do I consume these stacks? Well, there's a CLI that you'll see me use today. The CLI has a number of simple, verb commands. So appsody list, that'll show me the available application stacks that I can choose from. I'll use the appsody init command to pull down a copy of a stack, which is actually a Docker container, and a specific application template. That'll give me my application starting point. Then I'll use the appsody. I'm primarily going to use the appsody test command, and I can use that in my local loop to do implementation of my code and testing of my code as I'm developing it. And the tools I can use for developing, since appsody CLI will just run anywhere, I can use a number of different tools. If I want to do full IDE, I could use the CodeWind environment. I can use standalone appsody CLI plus Visual Studio Code or Eclipse. And it also runs in a hosted environment like with Eclipse Che or Red Hat Code Ready workspaces. But today I'm going to use Visual Studio Code. Once I'm satisfied my code is doing what I want it to do, I will do a build. At this point, I'm going to build a Docker container out of my application, a production version. And then I will do an appsody deploy, and that will deploy the application. We're going to deploy it here on IBM Cloud Kubernetes service today. And just a side note here, the last bit of this animation, you'll see like a CI/CD flow. This is part of our IBM Cloud Pak for Applications. It's a framework for automating deployment on top of Red Hat OpenShift. And it uses Tekton. Okay, so what's our programming exercise? So some of you may have heard of FizzBuzz. This is a classic simple kata. The idea behind a kata is to give a short exercise that teams can go through to practice their skills and techniques. So we're going to use it today to practice some skills and techniques and seeing how to do test-driven development. So I'll sort of read through it. So the idea behind FizzBuzz is that you've got a bunch of 11, 12-year-olds in school, and the math teacher's got a new fun counting game. And so each student is going to be counting off a number starting at 1, except when the number is divisible by 3, the student is going to say fizz. If the number is divisible by 5, the student will say buzz. If the number is a multiple of both 3 and 5, then the student will say fizz buzz. Okay, so now what we're going to do here in this programming exercise is we're going to create an API backend. We've got another team that's working on the front end, and we're going to equip all these students with a little mobile app that they can use to be able to just totally impress their teacher next time that this goes around. For the API backend that we're going to develop one API backend that just provides the correct response for a given number. And then the second thing, for those who want to prepare ahead of time, we're going to add another endpoint to this backend that gives a set of responses starting at the number 1 and goes up to an upper bound. Okay, so here's the environment that I will be using. We'll be doing all the demonstration on. On my workstation here, I'm going to be using the appsody CLI to create the project, and then I'll be using VS Code to be doing development. Now, while I'm doing my development, I'll actually be developing an application that is containerized. So this application stack that I will be using will be a containerized application. Technically, I wouldn't even have to have Node.js installed on my machine to be able to do this development work. And in fact, the ultimate runtime is going to be packaged in Node 12. And I don't have Node 12 on my machine right now, I don't think. But anyway, it doesn't matter. All of that is provided by the stack. Okay. Once we're all finished with the application, it looks good. We'll build a container image. I'll push that to IBM Cloud Container Registry. I'll talk a little bit about how that system works. And then we will deploy this to the IBM Cloud Kubernetes service using something called the appsody application operator. Okay. All right. So I'm going to pop over here to my demo here. And all right, so I've already run the appsody list command, and these are a number of stacks that we see. Appsody application stacks are organized by repositories, and I'm going to focus here on the incubator repository, and I'm going to use the Node.js Express application. So I'll start off here. Let's just clear this out. And I'm going to do apps. So with the appsody init command, you create an empty directory. And I do appsody Node.js Express. What's happening here is that the appsody CLI is going out to Docker Hub. It's pulling down the container and also the associated application template. It's expanded the application template. and it's now pulling down the container. And now I've got this is appsody project. So if I do ls in my directory now, I'm going to see I've got an app.js package, JSON file, and a test directory. Let's fire up VS Code. And I'm going to make this a bit bigger so we can all watch what's happening. Okay, so I've got a test. This application template comes with a test, and we're just going to extend this. But let's start off by running this test. So to run the test, I'm just going to run a task, and I'll run the appsody test task. I'll make this bigger. And the first time through, it's going to install a few dependencies. Okay, already done. And we'll see here, actually 2 sets of tests are run. The first set of tests are tests that are part of the application stack. These are endpoints that are provided by the framework. If you think about how application stacks might be used in practice, we could have a solution architect who is setting up the starting point for all the developers in an organization to use. And that solution architect can include things like metrics and other resources that are defined as part of the stack framework. Now, this is our test here that's running, and there's just a single test where we get on the /endpoint. So let's start working with building our application for our kata using TDD style. So the first thing I'll do is I'll close this terminal, and I'm in my test. I'm going to need to add a new test. I'm going to copy this. And back here. Okay, and so now I'm going to test I'm going to make API. Let's call my endpoint API FizzBuzz. Okay, so, and now I'm going to do a request. I'm going to now reach this. Okay, and that's all I need. So this is the minimal code to do a test. I'm going to see if this responds. And let's run this test. And of course it fails because I've got no code at that endpoint. Okay, now by TDD, what I need to do is write the minimal code to make the test pass. Okay, minimal code, here we go. Copy, paste. Okay, since I'm using Express, I just change this. I'm going to change this to called. Change that message log to that, and we're just going to send back an empty string. This is all I need to get a code 200 response back. So we'll save and run the test again. Okay, test worked. So all well and good, but now we've got our first opportunity for refactoring. Obviously, we're going to be adding some more code here to this API endpoint. So it doesn't make a lot of sense for us to just plop it here into app.js. So the first refactor we want to do is I'm going to head and we're going to put this into its own module. So let's cut out some of this extra stuff I don't need. I'm going to say app.use, and we'll do require. And now I need to have a path to my module. Let's call the module FizzBuzz. Okie dokie, that looks good. And let's just create a new file. FizzBuzz.js blank. Okay, I'm going to go over here so I don't live code the whole thing. I've got a little trivial express endpoint. We'll just paste this in. Good to go. All right. Save everything and rerun our test. There we go. So now I've refactored my code. Everything still works. Now let's start working on some of the functionality here. So let's write some tests for the functions we expect. So first thing that we know is that on this endpoint, I'm going to need to say fizz when somebody says 3. And I want to actually set these, we'll just, for simplicity's sake, we'll just set this off as a path. And I can keep this first check on whether I get status code 200. That's not a bad thing. And let's just change one more thing. So let's change expect. We're going to expect response.body to equal fizz. All right. So if I call it with 3, I'm going to expect to see fizz. That's my minimal code to express my test. Now let's see if verify that my test fails. Just a key part is once you've written your code, you need to make sure that it fails, right? Because then I won't know that any of the projection code I've written solves any problems yet. So, okay, so it failed. Not a surprise. Let's go to my module here. I already have a set check on that. Since we're dealing with the path, I'm going to add another route here. And I'm going to say if it's called with a parameter called num, I'm going to send minimal code here. Minimal code. We'll change it later. Send fizz. Now, obviously, you think about this, there's going to be problems down the road with this. That's fine. We'll fix that later. Let's test it. Okay, it works. No problem. All right, so let's do set. Now, one thing we know is not should just return fizz for 3. It's also going to do it for multiples of 3. Multiples of 3. So 9 is a multiple of 3. Let's call it with 9. Run our test. So you can start to see here, we get into a little rhythm. I think about the functionality of my application, and I write a test for the functionality of the application, and then I run the test, the multiple application. Now look at this, it returns physical, and it passed, right? So that was not necessarily the best test, right? So let's think about, obviously this is going to pass because I'm returning fizz all the time. Let's write another test here. Return buzz for 5. And the order in which you do these things is not critical. The key thing is that sort of like the coverage of your cases. All right, and let's do a run. Okay, and it failed because I got fizz when I was expecting to see buzz. Let's fix the code. So obviously we can't just return fizz all the time. Let's do something different. Let's define a variable and let's assign that to incoming parameter. And let's define a variable called out. And I'm going to send out. And let's put in a little logic here. So if now it's got to be a multiple of 3, so I want to do modulo 3. So if I is a multiple of 3, out equals fizz. And now let's copy this. If I is 5, okay, that looks like minimal code to make the test pass. Let's see if it passes. There we go, it passes. So now I'm returning fizz and buzz. Let's think about some more of the responses I want to have. And I'm returning it for multiples of 3. I also know that for 15, I should return fizz buzz. Because fizz buzz is a multiple of 3 and 5. And test. and it fails. Let's go to our code. Now, if I'm going to use a style where I've got ifs, I think the most slick way to do this is let's copy this if here. And if I do a conditional on if it's 3 and modulo 5, right? And we're going to say fizzbuzz here. And then I need to do else ifs here. Otherwise, I'll be messing things up here. So we'll do else ifs. Okay, that looks like minimal code for the test. Let's run it, see if it works. Okay, it's good. Now the other thing too, that since this is a counting game, for all of the other numbers, I want to just return the number, right? So in that case, we want to do a little bit more. Let's do another copy this block here. Okay, it should return the number. And you know, you could write this, but this isn't sufficient because I could just put like a out equals 1. I need a better test case for the number for the other numbers. So for example, I'm going to actually add another, I'm going to remove the done here because I only want to call that once in my asynchronous function. I want to put in another get. So I'm going to also get 4, return back 4, and we're going to put the done here. Done is just being used here in Mocha to indicate when I am finished with a set of expression assertions or expressions. So at this point, I'm actually going to now check to see if I send a 1 and get 1, I send a 4, get a 4. Let's see how it goes. Okay, and I definitely got a failure. Here we go. I expected something to equal 1. I didn't get anything at all, right? And if we look at my logic, right, I'm not doing anything here except for when I've got these conditionals matching. So I'll just have one more else statement here. Should have done the keyboard shortcut. All right. And if all goes well, okay, all my tests passed. So we're doing everything we're supposed to do. Now, just to sort of see it, now this has all been in the testing framework. We haven't looked at our API endpoint at all with any tools like curl or something else. With Appsody, I can do that. Let's just really quickly, I'm just going to run the appsody run command here from the menu. That's going to start the app up. Okay, listening on port 3000. Pop over here to the browser. We'll go to localhost 3000. Top level, I've got hello from Appsody because I didn't blow away that other route. Okay, API fizzbuzz, I get back 15. So my code's doing exactly what I expected to do. So that's my first part of my program exercise is my API endpoint, and that's totally done. Now, let's pop back here to code. I'll type Control C in here to kill that. And okay. So now let's write some tests for our endpoint that provides the range of results. Okay, I'm going to start by copying this piece here. We'll just paste the new block here for the range for the endpoint. Okay, and I want to be in one level. Yeah. That wasn't the right place. that looks okay. And we'll just go ahead and double check there. Might have an extra. Oh, that's my problem. Pasted in the wrong place. Great. Okay, let's fix this. So it's going to be API fizzbuzz range endpoint. And now on the status, I'm going to look for it. We're going to start off by expressing here. We're going to say it should return 50 elements. So I'm going to call this, and I want status to be 200, but I also want to do an assertion this time. So let's bring in the chai assertion library. You see a slightly different style here in addition to the sort of expect behavior approach. So I'm going to just say var assert, require chai assert. Okay. And here I'm going to say assert length of. I'll JSON parse the response.body. And so that's going to be, should be 10, 50. And if it's not right, I'll say something like that. Okay, and put a little semicolon at the end. Okay, so there's my minimal test of my API endpoint. And let's run that test. And of course, it fails. We get a 404, not found. There's nothing there. Let's add in our code for this. So again, I'm only adding code to fix my failing test. Copy this endpoint. Okay, and this is on range and a parameter num. Let's call this max. Okay, and now we're going to fill in an array here. So let's do var I equals params max. This is now an array. For loop I equals 0. I is less than. Oops. Nope. Let's think about this for a moment. I actually want that to be there. We're just going to say var I. There we go. And then I plus something like that. And so inside of this loop, I'm going to do out.push. And let's just pop the current index into the array. That's sort of close to where we want to be, right? Because after all, we want to have this thing being counting otherwise, and we just got exception processing around the other parts. So that looks like we're there. Let's run our test. Oh, we've got a typo here. I equals 1. Oops. There we go. And we passed. So there we go. So we now have this returning what we're expecting. Next up, we need to do the same kind of thing here with our functionality and what we're expecting in this range. And in the interest of time, I'm going to actually put in a few of these at once, all in sort of one go, right? And what we're going to do here is we're going to say it should return fizz for the third element. Three. And I'm going to do, instead of a length of assertion, I'm going to do equals, assert equal. And that's supposed to be is. Okay. And similarly, let's look at this. Okay, fifth element, and okay, should return fizzbuzz for the 15th. And let's look here, our logic here. I still need to think about this because I want to actually have just the third element. So it's an array, index 0.2. This is going to be array, index 0.4. This is going to be array, index 15. Okay, so looks like I've got all my checks here for this. So now I'm going to be making sure I get back 50 elements. I've got fizz, fifth, buzz, fizz buzz. Save and run our test. Okay, and no surprises here. This is all failing. But the good news is I've got code that does this. So this is pretty basic, right? So I just go here. I can now copy major portions of this. So this is the logic I want here. This does all the stuff I need. And I'm just going to put this in here. Okay, and I do need to change these to out.push. And some of you might be wondering right now, why isn't he refactoring the code at this moment? And the answer is, I could, but the goal is to write the minimal code to have a passing test. So, and then we'll refactor that. So let's just focus on the code for this block here. Oh, I forgot some semicolons here. Okay. And there's all of my blocks here. So I'm going through this whole thing. Out.push. And res.send out. So now I'm filling in my array. I'm starting at I, I'm going up to max. Looks good. One typo here. Missing a curly brace. Looks like. There we go. And run. I know this is taking a little while, but we're close to the end game. And of course, I've made a mistake. All right, so let's take a look at errors here. Expected 2, oh, 2 to equal fizz. Expected 4 to equal buzz. Expected undefined equal fizz. Let's look at our code here. Now what's going, so what's going on here is 2 is my index, but I'm expected to be fizz. So the application's returning 2. So the first problem I've got is my range. Oh, I can start at 1, right? And I need to equal that. So now the third element is going to be 3. Okay. Run task. Should return fizzbuzz for the 15th element. I think I made a mistake in the test. Let's look at the test. Yeah, I did. Because I was sure that the other code is right. This is the beauty of live coding. All right, I live code like lightning. Never do the same mistake twice. Okay, so now our code's working here, but obviously this is pretty ugly. So let's refactor. Let's create a function. I'm going to create a function called fizzbuzz. And I'm going to, okay, return out. And I'm going to say var I equals num var out. And primarily the reason why I'm using these same conventions is that I'm just going to copy this whole block of code. Okay, so now this whole block of code is here. I'm going to now do some major refactoring. So I've got this whole loop. I no longer need to do this whole loop, right? I'm just going to loop through here, get rid of that, out.push all my function. Clean up a little bit. Okay, and that's this function here. So this is the block of code that I've been working on with the current set of tests. But obviously, this block of code also has redundant stuff here. So let's shorten this one up, and this one gets shortened up a lot, right? Because all I need to do is call fizzbuzz. So here I'm going to do res.send out. I'm going to call with. Okay, so that's a pretty big swing across the code, but the reason it's safe to do that is I've still got tests for both of these endpoints. And let's run our tests again. And unless I made a live coding error, this is all just going to work. Ah. Okay. Expected to equal 1. Okay. Let's look at my parameters in my code. Okay. Fizzbuzz num equals num. Ah, not max. There we go. I was thinking about that. On our test. All right, done. Great. So let's make a container. Let's talk a bit. Let's recap what we did here while the container is building. So I'm going to log into my Kubernetes cluster. And I'm also going to log into the container registry. So because when I build my container, I want to push it to IBM Cloud. So I'll do IBM Cloud CR login. Okay, and I'm logged into the IBM container registry. I'll copy this command here. Okay, so I'm going to appsody build, and I'm going to tag this container image in a namespace in my container registry, and I'm going to push it to this path. So it's going to go to the IBM Cloud Container Registry. So it's going to take about a minute 20 or so to do this build. While it's doing the build, let's look quickly at some additional information here. And I'll go over to the presentation again. So we've been talking mostly about Mocha and the Chai test framework. So Mocha is a testing framework for Node.js, and Chai is an expression language. It's a library that's added. There's other testing frameworks. Last time, Oliver was talking a bit about using Jasmine for doing browser-based testing. There's JUnits commonly used for Java, RSpec for Ruby, and Python also includes something called unit test module that you can bring in for testing. And then you also see for something that's very popular in addition to a capability that's a developer centric on a particular assertion, a style called behavior driven development. And Cucumber is a commonly used tool for that. And that's used, it was originally developed for Ruby, but it's got language bindings as well for using with Java and JavaScript. So I bet our build is almost done. Okay, so it's pushing it right now to IBM Cloud. And I'm going over here to IBM Cloud dashboard for a moment. So here's my cluster that I've got. And inside here, when you click into the cluster from this area here, you can click on the Kubernetes dashboard. See a warning, this expires in 26 days. This is actually a free cluster. We have instructions as part of our Digital Developer Conference replay, and I'll show the link in just a moment, where you can sign up for IBM Cloud and get your own free Kubernetes IBM Cloud account that you can spin up free Kubernetes clusters in. Also within this, we include a no-cost registry service. So inside that registry, we can store up to 500 megabytes at no charge. So here's my image here. It's been pushed. One thing that's interesting about the IBM Cloud Container Registry Service is that we include a security scanning tool, the IBM Vulnerability Advisor. Now this is a really minimal container image. It's based on the Node 12 Slim image, so it's going to have a passing test here in a moment. We won't wait for that though. Let's go ahead and deploy. Now, one thing that happened when I did my appsody build was that I created a resource file here. This resource file, appdeploy.yaml. Put this down. Okay. This resource file specifies something of a Kubernetes kind called an appsody application. And there's an operator called the application operator, or appsody operator, which will deploy a custom application to Kubernetes or to Red Hat OpenShift based upon the specification that we've got here. Now here we see it's got the image name is specified to the IBM container registry and the path of what we pushed. And a number of things will specify liveness pros for Kubernetes. I need to add to this the poll secret to use so that my Kubernetes cluster can talk to the container registry. So I'll just add that here. Save. And now I'll go back to my terminal. And we will run appsody deploy. Now, I've already created the container image and pushed it to the registry. So this time when I do appsody deploy command, I don't need to do a build. Now, this is a scenario where we are going to be sort of functionally testing our application by pushing it to a Kubernetes instance. I could just as easily, if I had Kubernetes running on my local machine, use this same tooling to build a container image and say, push it to Docker Hub and then deploy it to Kubernetes directly on my workstation. Okay, so let's look at our, look at pods, okay. All right, and I see an appsody operator running, and I also now see a FizzBuzz pod running. Well, it's starting. And let's do git. Go get service, and I'll see here I've got port 30236. Let's do IBM Cloud, KS workers. So by default, on the IBM Cloud free Kubernetes service, we don't include an ingress, but you can still deploy applications and expose them as node ports. All you need to do is define the public IP address of the cluster. There is as part of our Digital Developer Conference, there's also a lab that really goes through a lot of these details and in a lot of specifics that you can follow along as well. Okay, so I'm going to copy the public IP address of my cluster. It's a single node. Back over here, let's put in HTTP. Okay, that's the IP, and let's get my node port 30236. That's where my application is visible on the cluster. Boom, hello from Appsody, and let's put in a range of 50. And there we go. I've got fizz, buzz, and ending up with the 49th element, which is 50, says buzz. So key things here, we start off at 1, 2, there we go. So our backend's done. We've been able to use test-driven development to create a backend and actually deploy it on cloud. Now, hopefully the front-end team that is working on the front end for the students has got that done on the mobile side, and they'll be all ready for classes. I suppose we got virtual classes now everywhere here in the US, but wherever they happen to be, they're going to be ready. So let me go back here to the presentation. I do want to put up one last slide here that's got some links. So previously I mentioned the IBM Digital Developer Conference. This is a conference that we ran live globally last year digitally, and it's now in replay form. You can tune into it here at this link. You can register for it. In that, we've got 2 tracks. We've got a machine learning track and also a cloud native track. In the cloud native track, we've got some great content, including an additional lab on Kubernetes, which sort of builds on some of the ideas that you saw here today from a developer side. It'll also be a great chance to get hands-on Kubernetes if you've not done before. Also, if you've found this interesting and want to learn a bit more about Jasmine and the testing framework there, and also continuous delivery testing capabilities of IBM Cloud, check out last month's Webcast Wednesday about DevOps testing for beginners. And then also, I'd also recommend if you want to take a look at a Java and JUnit example of TDD, the bowling game kata. You can just do a Google search on that. There's a really nice presentation here by Bob Martin that goes through how to do this kind of TDD flow where you write the test, minimal code, and then write the solution and production code and do refactoring. And the example is a really solid one, and it shows a great way to sort of think about how to solve a problem using test-driven development. So with that, that's what I wanted to really talk to you about today. I hope this has been informative. As always, tune into IBM Developer, and we do have additional Webcast Wednesdays coming up. Are there any questions, Scott, that we saw in the chat to cover? Okay, fantastic. Well, either that or it was like it's tough. Seems a little tedious, but I think once you get the flow of it, and I would certainly recommend if you're a Java programmer as well to check out the bowling game kata. It's a great chance to sort of see how this style works in action. And the nice thing is, if you're doing this, you're going to have your unit tests already done. No, like writing your code and then going back and writing unit tests for coverage. Your unit tests are done at the same time your code is done. So with that, I'll thank everybody here for joining us today, and we look forward to catching you on the next Webcast Wednesday.